So in this section, I would like to discuss what is the difference between classification and prediction. Yeah. So I took this definition from the book. The book that I use is the data mining book from the Jiawei. So this is the book, Jiawei, Michelin, Campbell, and Chen Pei. So the authors use the definition of prediction. So we are going to learn what is the difference between classification and prediction. So the classification, it is to predict categorical class labels. Categorical is the keyword. We want to check whether it is a discrete or nominal. So for example, this one. I have the information about age. I have information about income, student, and credit rating. Now, the person number one, his age is less than equal to 30. And then his income is high. Whether he is a student or not, so it is no. So it means he is not a student. The credit rating is fair. Fair is like medium. And we know that this is the decision. By computer, if you look at the data, we have two kind of options, no and yes. So I can say that this is the possible target. This is the possible target dimension. Why? Because it is a kind of decision. If I know the information from the object, okay, if I know the information from the person, so I can predict whether the person will buy computer or not. So if it is yes, then it means the person buys computer. If it is no, then the person did not buy computer. So we call this is the classification because it predicts the categorical class level. Categorical class level. This one, no and yes. So the classification, it will classify data or construct a model based on the training set. This is the training set. And the values, which is the class labels in a classifying attribute, and use it in classifying new data. So let's say if I have a new data, maybe the person is more than 40 and the income is high and the student is no and the credit rating is fair. So can you predict whether the person will buy computer or not? It means, yeah, we need to learn from the data. So this kind of application, it is, you can see from the credit approval. So in the credit approval, the bank will check your profile and then they will give you the approval, yes or no. Target marketing. So usually the companies have the customer profile. So they will check the customer profile and then they will determine whether you are the good customer or bad customer, or maybe you are the promising customer or you are not the customer. Medical diagnosis. Yeah, we know when we do the COVID-19 test, so the result will be positive or negative. Fraud detection. Fraud detection, yeah, if you have email, okay, you can see something like spam. Yeah, so the email is valid or not valid. In the fraud detection, it is about the credit card, whether the credit card transaction is good or not good. Yeah. So if we are dealing with the prediction, so based on the authors, it is to model the continuous value functions. So it can predict unknown or missing values. So sometimes it refers to forecasting or regression. Forecasting is similar term with prediction, but it is intended for the time series data. The time series data means I will have some time. I know that January 2020, February 2020, March 2020. So can I know what is the demand on April 2020? So there's a time sequence. Regression is a method to predict continuous values. So if you have this target dimension, you can see here now, we have the same object. We have the same object. But the decision is the price of the computer that the person bought. So let's say 0. Okay, it means the person did not buy a computer. 0, the person did not buy a computer. Okay, 1350. Maybe this is in dollar. Okay, I know that the person bought a computer and the price is 1,350. So when we have this label or this continuous label, we can do a prediction. Yeah, this is only just the terminology given by the author. When we are dealing with the prediction, usually we use it for the continuous value. But in the literatures, in some papers, you will see regression. Maybe you will see forecasting, but in the forecasting, usually this is for the time series data. So if you already know the supervised and unsupervised learning from the image data, so what is the supervised and unsupervised learning in the record data? So this is the record data. So if you return back to the previous definition, so the supervised learning means we have the labels. So the training data, which is the observation, measurements, are accompanied by labels. So we have this label. So the label, yeah, can be anything. It can be the decision, like this one. This is the decision. So in our case, there might be a different examples. If you still remember the data that I gave to you about the golf, play golf. So when you check the play golf data, it is also related to the supervised learning. So the decision is whether they play golf, yes or no. So that's the decision. Or we can say that is the label. And any other things we will check in the other examples. So the new data is classified based on the training set. So we have this is the training set, for example, and if we have another data, we will check based on this one. If we are dealing with the unsupervised learning or clustering, it means the class labels of the training data is unknown. So I do not know any decision, no decision, no label, no information for the target. I just have this kind of data. So given a set of measurement, the observation and etc. with the aim of establishing the existence of classes or clusters in the data. So if it is unsupervised, yeah, we need to make grouping, we need to make clustering, or we need to make some kind of method for the self-supervised learning and etc. That's the big difference between the supervised learning and unsupervised learning when we look into the record data. So when we do with the classification, there will be two steps. The first is we will do the model construction. And the second is we will do the model usage. The model construction means we describe a set of predetermined classes. Each tuple or sample is assumed to be to a predefined class as determined by the class label attribute. So the meaning is this one. We assume that this person, I know that he didn't buy a computer. Okay. So yeah, this is the case in the classification. So we want to construct the model with this information. The set of tuples used for model construction is training set. So we have the training set. We call this is the training set. So a bundle of data that I know about the target, so I put it as the training set. The model is represented as classification rules, decision trees, or mathematical formula. So we will make the model based on the training set. After I have the model, I need to use the model. So we call it the model usage. It is to classify future or unknown objects. We are going to estimate the accuracy. The accuracy means, yeah, we want to check the known label of the test sample is compared with the classified result from the model. So we will check later what is accuracy, because we will need this accuracy. This is the percentage of the test sample that are correctly classified by the model. And the test set is independent of the training set, otherwise outfitting will occur. You can say that from the model construction, we will have a training set data, and for the model usage, we need to have the testing set data. Okay, so there will be two kinds of data set. The first is the training set, and the other is the testing set. This is the picture to represent the two-step process. So model construction means I will have the data and then I will split into the training set and the test set. And after I have the model will be used to check the accuracy from the test set. The model usage means a model is evaluated using the test data set. And model construction means a model is generated using a training data set called the training set, or this is also the testing set. So there are some issues with this kind of the classification. First is the data preparation. When you have your data, you need to clean. So you still remember the data cleaning. Some data might have missing values, or some data might have noise. So if you don't handle this noise, if you don't handle the missing values, so you cannot make a model. And also some relevance analysis or feature selections. So you need to remove the irrelevant or redundant attributes, because if you include the redundant attributes, then the model also will not be good. And the data transformation, how we can generalize or normalize the data. If you have the data, let's say you have the data of age. Age is a number between 0 until maybe 100. And let's say you have another attribute, salary. In Korea, the salary, the minimum salary is 1 million. Okay, let's suppose 1 million. And the high salary, I don't know, maybe 100 million. Okay. So the unit is different. We have the age is from 0 until 100, and the salary is from 1 million until 100 million. Then we need to transform into some format, like you learn about the normalization. So we need to generalize the data. So the classification will be good. So when we are going to evaluate the classification, so we will learn later about the classifier accuracy. The classifier accuracy means how the model can predict the class level. And the predictor accuracy means how guessing value of the predicted attributes. So we will learn those things. And also the speed. The speed is most important, because when you do any kind of AI or any kind of machine learning, if the speed is very low, then you cannot do in the real time, or sometimes we cannot wait. Time to construct the model, the training time. So in my research, we are having a lot of data. Last time we analyzed like 6 gigabyte data, and my students run the performance until 3 days. Of course, it is very long. So we need to consider what is the possible model. Time to use the model. So classification or prediction time. So usually this is not that long. And we need to think about the robustness, how to handle the noise and the missing values. Some of the data still have missing, or some of the data still have noise that we do not know. Then how the model or the classification can handle it. The scalability, whether it is efficient in this precedent database. So if you have a lot of size, of course you need to consider how it is efficient in your database. Interpretability. So you need to understand and insight provided by the model. So when you learn with the neural network, if you know about the deep learning, so you may learn later, and it is difficult to understand. So this classification method should be interpretable. And other measures, we need to check the goodness of rules, such as decision tree size or the compactness of classification rules. Okay, just simple learning check. What is the difference between classification and prediction? It is to predict the categorical class label. What is prediction? It is to model continuous value function, and yeah, we can also do for the predict continuous or class label. That's the difference, the categorical and the continuous. Mention the two steps of classification process. We have model construction and model usage. For model construction, we will do the modeling with the training dataset. For the model usage, we will use the testing dataset. Okay. What is the difference between supervised and unsupervised learning? The supervised learning, the observation contain class label or just contains label. Okay. The unsupervised learning, the observation does not have any label, and we can create some clusters. Sorry, not cluster. Can I change this one? Oh, sorry. Okay. So for the supervised learning, we don't have the class or the label, and we can group or cluster the data. So what are the issues on the data preparation? We know there are 3 issues for the classification. Okay. So the first is the data cleaning. The second is the feature selection. What are the features that would be good for the classification? And then the data transformation. So those 3 are the basic. Of course, there might be some details later. So what are the issues on the evaluation classification methods? So there are many things. Yeah, we have the accuracy, we have the speed, robustness, scalability, interpretability, and measures. Okay. Okay. Now let's learn about the algorithm. So you already see this data, and we will learn one algorithm. We call it the diffusion tree induction. Usually the literatures it mentioned as the ID3. 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 It is the induction decision tree. Okay, so they make it as this shown. As I mentioned to you, we have this data: age, income, student, credit rating, and bias computer. We will create this kind of decision tree. So this is the decision tree for by computer. Let's say we have this decision tree. So what does it mean by this tree? Okay, I will check first based on the age. If the age is less than 30, I will check whether the person is a student or not. If the person is not a student, oh, okay, then I know the decision that he will not buy computer. If he is a student, okay, this guy will buy a computer. Or we can have another branch. If the person is in between 31 and your body, the decision is yes. So, yeah, all person who are in between 31 and their body will buy computer. But if the person is higher than 40, we will check the credit rating. Okay, if the credit rating is excellent, oh, he didn't buy computer. But if the credit rating is bad, oh, he buys computer. So this is the way to interpret. This is the way to explain this decision tree. So the question is, how we can create this decision tree? So the basic algorithm is using a greedy algorithm. Tree is constructed in a top-down recursive divide and conquer manner. If you learn with the data structure and algorithm class, you will know the concept divide and conquer. So all start at all the training examples at the root. So we assume at this moment, let's just use the attributes which is categorical. Okay. So you can see all of them: age, income, student, credit rating, they are categorical. I will teach you later with the continuous values how we can use the discrete values, the continuous value. So examples are partitioned recursively based on the selected attributes. So we will select one attribute and then calculate. We will check another attribute and then calculate. We will check another attribute and then calculate. We will check another attribute and then calculate. And we will test the attribute. Test attributes are selected on the basis of a heuristic or some statistical measures. So we will learn about the information gain. There will be some conditions for the stopping partitioning. All samples for a given node belong to the same class. So if no, it should be belong to no, 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 no. Then if it is belong to the same class, then stop. But if still can be divided, then yeah, we can split to yes and no. Or there are no remaining attributes for further partitioning. So if there are finished, no attribute. So after we have age, income, student, credit rating, and there is no other attribute to check, then we can finish. or there are no sample left. So if we have very small sample, that's why it is, yeah, we can get very fast decision, but maybe the result is not good. We have the first selection method. We call it information gain. The information gain is used in the ID tree, the decision tree, and there's another algorithm. It is called C4.5. We will select the attribute with the highest information gain. Let Pi be the probability that an arbitrary tuple in D belongs to class C. So it will be estimated by the Ci, which is the number of Ci divided by the Di. Di means the total data. So we will check the entropy. The entropy, when we use this entropy or the information gain, okay, we will use this formula. This is the sigma, and we have the minus Pi log base 2 Pi. So Pi is the probability. And what we are going to check later, we need to check the information needed with this formula, and then we have the information gain with this formula. I will just go to the example for the easy explanation. So why we need to use the entropy? Okay. So let's see this concept first. The entropy will be, let's suppose we have binary. You still remember binary? We have 0 and 1. We have the coin, coin. In the coin, we have only 2, which is front or rear. Let's suppose I have 2 times. Okay. 2 times of coin toss. So the first will be the front, and the second will be the rear. Then I can have the probability is half, and then I have the rear also half, 1/2, 1/2. So if we use this entropy, we will just apply the formula. What is the probability? The Pi is the probability log base 2 of the probability, half, minus half, which is the probability log base 2 half. If we have half and half, then the entropy is 1. What does it mean? This is 1. If it is 1, then we can split. We can know that there are 2 possible results, which is front or rear. But what about if we have another experiment? So we toss the coin, okay, 2 times. But after we toss the coin 2 times, all results are front. And the probability will be 1. And if we calculate with this entropy, 1 log is to 1, then the entropy will be 0. If it is 0, or this is 0, it means it is already in one class. So if it is already in one class, you cannot split anymore. So that's the reason if we have the highest value, okay, so later we call it with the highest entropy or the highest information gain, we can split. So we need to check the highest value. The smallest value, yeah, we don't need to check because it is already in one class. The probability is already 1 in one class. Then finish. Let's say we have 2 coins. So it will be more complicated because we need to check the possibility if the coin 1 is front and the coin 2 is front. The coin 1 is front and the coin 2 is rear. The coin 1 is rear and the coin 2 is front. The coin 1 is rear and the coin 2 is rear. And for example, I have this probability. So I can use this entropy formula and I get the result. The highest is 2. I can have this probability and I can use this entropy formula and I have the value is high, but it's not that high until 2. But if I have this probability, so it is very perfect in this class. We can see that all happens only with the coin 1 equals to real and the coin 2 equals to real. So there is no other possibility. Then the entropy equals to 0. If it is equal to 0, then we can say that, okay, all the data will be toward this class. So I got also this word from the professor. High entropy, low entropy is zero. So let's see if we have this data. How we can apply that entropy value? Let's say the class P is the person who buy computer, yes, and the class N is for the person who buy computer, no. So we need to calculate. If we don't know anything about the attributes, okay, let's say maybe we want to start from the age, but let's say I do not know anything about the age, income, student, credit rating, so I just know about the buy computer. We have P is 9 and we have N is 5. You can check. Yes, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. What about no? 1, 2, 3, 4, 5. Okay. So the total data we have 14. Now, how can we calculate the entropy? Based on the formula, we need to make the probability. So the probability of the positive is 9 divided by 14. Because we have 14 data and the positive we have 9. And then we put minus log base 2, 9 divided by 14. And then minus 5 divided by 14, log base 2, 5 divided by 14. It represents the negative. So the result will be 0.940. This is the information gain when we do not consider the attribute. So we can go to the next. First, we will check based on the age. What is the age? The age is, we have the yellow, the orange, less than 30, less than 30, less than 30, less than 30, and less than 30. So we can make the category. If it is less than 30, I will categorize the P and I will categorize the N. What is the P. We have 1, 2. So we put P is 2. What is the N? 1, 2, 3. So we put 3. So the total from the edge less than equal to 30 is 5. What about 31 until 40? We have 1, 2, 3, 4. Okay, we check. This one is yes, 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 yes. Okay, so there are 4 P, but the N is 0. What about this greater than 40? Greater than 40, we have 1, 2, 3, 4, 5. Okay, then we will check how many yes, 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 yes. So there are 3 yes, so 3 P, and then we have 2 N. Okay. After this one, then we will check the information gain. This information gain will be checked one by one. We will get the value 0.971. This is 0 and this is 0.971. Do you still remember what does it mean by 0? Based on this formula, if it is 0, then it is perfect. Then you cannot split anymore. So it means, yeah, it is perfect. All data is positive, so you cannot split. So we can make the formula into these numbers because we have 5 data. So I would like to check if the age is less than equal to 30, then I will do the probability is 2 divided by 5, log base 2, 2 divided by 5 minus 3 divided by 5, log base 2, 3 divided by 5. This is for the age. Yes, the age less than equal to 30. We can also do with the age 31 until 40, and we can do with the age greater than 40 with the same formula. After that, we will make the information in for the age attribute. How we can get this one? We know that there are 5 data here, there are 4 data here, and there are 5 data here. So for this information gain in the age attribute, we have 5 divided 14 multiplied by the I 2,3, which is this one, and then 4 divided by 14 multiplied by the I 4.0, which is this one. Yeah, every number multiplied by 0 will be 0. And then 5 divided by 14 I 3,2, so it will be this one. So the result of this information gain is 0.694. At the first part, we know that the information D, so from the total data, we have 0.94. Okay. So the first, this one, we have 0.94. And we will use this one to calculate what is the gain, what is the information gain of the attribute age. 0.94 minus by the number that we obtain from this calculation. So we can get this 0.246. This is for the its attribute. So can you do with the other attribute, income, student, credit rating? Yeah, we will do the same, and we will get this one. The gain for the age is 0.264. The gain for the income is 0.029. The gain for the attribute student is 0.951. And the gain for the credit rating is 0.048. Among this one, we will choose the highest information gain. And the highest is DH. And this is the most discriminating power with regard to the attribute, the target attribute. So we put the H as the first attribute to be the decision tree. So we call this is the most discriminating power, or the most significant attribute, or the most important attribute. Okay. And then after this, we will again select another attribute. What is the possible attribute for the next decision with the same method? And we get this tree. Okay. Okay, let me stop here. So let's have a break. Okay. We'll continue after the break.